Good morning, everyone, and welcome to Episode 3 of PLASTICAST, the Pacific Northwest Consortium on Plastics podcast. I'm your host, John Dickens. I'm a master's student at Oregon State University, and I study the impact of microplastics on marine and estuarine animal behavior and physiology. PLASTICAST is a mini-episodic series featuring scientists on the latest in plastic and ecotoxicology research, legislators in policy development, and other interested stakeholders. As we continue learning about microplastics and their impact on the environment, we'd like to explore the regulatory side of the issue. Joining us today is ecotoxicologist Dr. Scott Coffin of the California State Water Resources Board, which is part of California's Environmental Protection Agency. Thank you for being here with us today, Dr. Coffin.
Happy to be here.
Scott, would you briefly discuss your background and how you got involved with microplastics?
Sure. So I started my PhD in 2014, University of California, Riverside. And at that time, plastic and pollution in the ocean was sort of a buzzword on the internet. And I was interested, just like many people were. And I pitched it to my then advisor to study the effects of plastic leachates on estuarine environments. And he bought it. And so 4 years later, I finished my PhD and I started working at the State Water Resources Control Board. And I was pretty early on promoted to research scientist position where I was focused on drinking water, and in particular, Senate Bill 1422, which was passed in late 2018, requires the State Water Resources Control Board to define microplastics in drinking water and sample them and determine the health effects. And so typically the State Water Board, they work within a large CalEPA framework where the toxicologists are in OEHA, or the Office of Environmental Health and Hazard Assessment, and the engineers and environmental scientists are in the State Water Board. And for this particular project, they needed someone who was extremely specialized in microplastics. And so this is why I'm one of the only toxicologists working in the State Water Board right now, due to my background. And it's been really exciting. I've only been working on this project with the State Water Board for a little over a year.
So you bring up a good point about Senate Bill number 1422, about the California legislature adding microplastic regulations to California's Safe Drinking Water Act. Now, this provision requires the state board to adopt a definition for microplastics in drinking water by July 1st, 2020. This is amazing news, Scott. The California State Water Resources Board is poised to become the first regulatory agency in the world to specifically define microplastics in drinking water. Can you discuss the details of this provision and what this could mean for California's water resources?
So with the definition of microplastics, typically we don't consider what matrix it is in. And this is due to the fact that there's no regulations for microplastics in drinking water or other water matrices in any government agency worldwide. There are different regulations that have to do with intentionally added microplastics, specifically some bills passed by California, which was quickly passed by President Obama back in 2014 or 2015, banning microbeads. And the European Union is very recently considering a restriction proposal for all intentionally added microplastics. And so looking at the material as it's on its own is one thing, and then looking at the material in a specific matrix with specific endpoints that are associated with it, i.e. microplastics in drinking water, is a completely different thing, because we're no longer thinking just about what plastic is as a polymer type, as a particle type, but we're considering the human health impacts, which are very poorly understood. There's very few publications that have come out on the human health effects, especially as it pertains to the drinking water route of exposure. And so the first step that the legislature tasked us with is just defining what microplastics in drinking water is, so that we can further ask the right questions. And the way that we're doing this is we're collaborating with a number of research institutions from around the world. We're contracting with the Southern California Coastal Water Research Project, also known as SWIRP, it's a research institution in Costa Mesa, Southern California, that typically works on ecotoxicological, specifically marine ecotox issues. And they've been working with plastic for a long time, but because of this bill and because of our contracting with them, they have invested a lot into microplastics specifically. And they're currently running a training lab where they'll train any research institutions on the equipment and how to extract and characterize microplastics, not just in drinking water, but they're also using this opportunity to standardize methods in fish tissue and wastewater, stormwater, sediment. And so this is a really exciting opportunity where we see the regulatory need and the science need of having standardized methods, and they're finally coming together and providing the impetus and funding, huge part to finally narrow down and get what we need to have replicatable studies and comparable results. So it's a really exciting arena to be in right now. It's rapidly developing. When they passed Senate Bill 1422, I don't know if the legislature realized that the timeline that they put in the initial bill would actually pass. Typically they aim high and they get like the middle road. But with this particular bill, we had from passing in 2018 to the regulation in 2021, that's a really, really short amount of time. Typically with a lot of these bills that have to do with regulations, it's much longer timescales. And so this is a really fast track, really fast-paced, exciting project. And I really hope that we're able to achieve the goals that we want to during the coronavirus pandemic, which is, it seems to might be impacting the work that we're doing, but I have high hopes that it's not going to make a huge impact in the long run. So specifically, we have to define microplastics in drinking water by this year. And this is to set us up for the sampling and analysis plan, which we need to have a 4-year plan by July of 2021 of how we're going to sample, where we're going to sample, what we're going to be looking for in drinking water across the state of California. And I can tell you right now that it's going to be a targeted plan, because based on what we know about microplastics in drinking water, we don't have enough information about the human health effects to really go out and write a regulation that's going to be inclusive and statewide and manage resources wisely. We want to collect information in a very focused and thoughtful way so that we can make decisions in a conservative manner. So we're not just making people look for microplastics in their water sort of indiscriminately, just because we think it might be there or we think it might have human health effects. So a lot of these steps are happening sort of concurrently, figuring out what the health effects are, figuring out what microplastics are, figuring out if they're in drinking water, what type of treatment techniques, the standardized methods, everything is happening all at once.
As new scientific information becomes available, Scott, the proposed definition of microplastic can change. The Safe Drinking Water Act allows room for this. Can you discuss the current consensus on the definition of microplastics in drinking water and why the broader definition of microplastics in general seems to change so often?
Yeah, that's a great question. So I think the definition of microplastics has evolved so much since the 1970s when we first started being concerned about small plastic particles in the ocean. And at first, the definition was sort of around 5 millimeters or so. 4.75 was a number for a while. Anything smaller than that is something that we would expect to behave differently than larger plastic particles because they can be ingested. And over the years, we have refined that to be 5 millimeters really seems to be the consensus. And that has to do more with sieve sizes and standardized sieve sizes, as well as in 2015, the California State Water Board passed what's known as the trash amendments. Essentially, stormwater that goes into the ocean needs to capture microplastic particles, capture plastic particles that are larger than 5 millimeters. So this 5 millimeters becomes sort of a regulatory value at this point. And so it makes it really easy to set that as the upper limit. For the lower limit, it seems like the consensus is there is no lower limit. And that's how it's been for almost since the beginning. Some people have put the lower limit at 1 micron, and that's just based on either technical feasibility, it's harder to measure particles smaller than 1 micron, or trying to keep with SI units, keep microplastics in the micro range, in which case some people say it's 1,000 microns to 1 micron, and then you need another category for nanoplastics, and then mesoplastics and macro. And I think these distinctions are very important because it helps with communication, not just between scientists, but also between stakeholders. If we're going to be explaining to people that they have microplastics in their drinking water, they might think what they see in images, which is typically millimeter-sized plastics or larger that you can actually see with the naked eye. Those are extremely unlikely to ever be found in any drinking water sample. Typically, we're looking at the very smallest end of the scale between 1 and 10 microns. And that's something that you'll never be able to see with the naked eye. And we have a very difficult time characterizing it. There's a lot of uncertainty when you're looking at those small particles. And as we go even further down into the nano range, eventually the methods are going to be there. We're going to have to use a different terminology. But when it comes to the regulatory definition, we want to make sure that definition is not self-restricting. So if we think that the small nanoplastics, small nano-sized plastic particles are the most harmful for humans via drinking water, we don't want the word nanoplastic to be a category that is different than the big scheme of microplastics. So that's sort of one way to think of it in a regulatory sense, which may be a little bit different than how we've been using it in scientific publications, where it doesn't have that same sort of legal weight attached to it. As far as the polymer, how do you define plastic? It seems rather intuitive. A lot of us work with plastic. I mean, everybody knows what plastic is, and first stroke looking into the literature, it's like, obviously it's a man-made synthetic polymer. And when you actually get down into how to define all of those words, it gets really tricky. And this is something that I explore in the draft staff report. And I'm really lucky that the European Union has done a lot of the groundwork and explored sort of the philosophical terms that we use, like polymer. What does particle mean? Is there a such thing as a particle if it's 5 nanometers? Or is that just dissolved? What's the line between a nanoparticle and just a molecule in water? And coming back to what is plastic, we're discovering that there are so many types of plastic that don't necessarily meet the industry definition of what plastic is. For instance, the International Standards Organization in 2013 defined plastic as a material that can be formed through flow. And that has to do with how the material is made. And it specifically excludes elastomers, as well as other types of polymers, like biodegradable polymers might not be included in that. And then taking the definition a little bit further, ASTM, which is a standards organization, they define plastic specifically as particles that can be formed by flow, except fibers and tire wear particles and paint. And so now they've really excluded a lot of what toxicologists are most interested in with the synthetic polymer problem, namely textile fibers. And as I understand, John, a lot of your work that's dealing with tire wear particles. And so in thinking of the definition, we've had to sort of break away from these standardized definitions of what plastic means and just take a big step back and really consider what do we care about? Do we care about a persistent polymer? Because that's traditionally the thought of why plastic doesn't belong in the ocean, because it doesn't break down and it's man-made. Or do we just care about any man-made particle? Do we call cellulose that's been modified physically a man-made particle? In some ways it meets the category of synthetic, but it's just cellulose. It's just plant fiber. What if we chemically modify the cellulose? So cellulose acetate is an example. That's cigarette filters. We find those. That's the most common micro debris ever found. I mean, it's the most abundant, and it breaks down faster than maybe polystyrene, but it's still persistent. And we're finding that a lot of the leachates from this are toxic. So we need to find a way to include all of these polymers that could be concerning without preemptively excluding polymers that we don't know if they're toxic to humans or not yet. So this is sort of the approach that the European Chemicals Agency has taken. One thing that they did, one thing in their definition that they did right off the bat was they excluded all biodegradable polymers. And they have a very set way of determining biodegradability. This has to do, again, with the regulation part. Scientifically, if you're concerned about the polymer's persistence in the environment, then you might want to put biodegradable polymers into a separate category. But if you're looking at the endpoint, which is, in this case, in drinking water, human health, we don't really care how fast it degrades in the environment. We just want to know if it's in your drinking water and if it's toxic. So in that case, that's a case for more inclusion. And that's why the definition that I proposed for microplastics in drinking water for the State Water Board, it may be the most inclusive definition of microplastics to date, as well as the most well-defined in terms of terms. A lot of the definitions, like the US EPA definition, very inclusive, but the terms might not have that legal defensibility that a regulatory term typically has.
So, Scott, I recently read a study by clothing company Patagonia in conjunction with UC Santa Barbara, who they found that when clothes made from synthetic material like nylon or polyester, when those materials are washed, up to 40% of the synthetic fibers they shed evade capture by wastewater treatment facilities and are released into surface waters. This is alarming, as most of the clothes that I own contain some degree of polyester or nylon. So I'm asking, what is one thing that I could do to reduce the chances of fibers from my clothes finding their way to the ocean?
So if you really want to prevent fibers from going from the washing machine into down the drain, there's a number of filters that you could buy and put on just about any washing machine. They're relatively inexpensive. Coraball is one of them. Filtrol, Lint Lover, spelled with LUV-R. And if you're interested in learning more about those types of filters, you could look at Chelsea Rockman's work from University of Toronto, and her lab has been looking at these different techniques, these filtration techniques, really deeply. And actually, it's funny that you bring that up. The California legislature has introduced, I think, 4 bills right now that are sitting in the legislature, all aimed at installing these filters in different washing machines around the state.
Well, thank you so much for joining us today, Dr. Coffin, and thank you, listeners, for catching the 3rd episode of PLASTICAST, the Pacific Northwest Consortium on Plastics podcast. Tune in for bi-weekly episodes as we explore the world of plastic pollution, research, and policy. Find us on Twitter at PNW Microplastic. That's PNW Microplastic. I'm your host, John Dickens. Have a great week, and when you go to the store, remember to bring your canvas bags and reusable containers.